And welcome to the Daily Space Weather. We're looking at a composite image here of the closest star, El Sol, otherwise known to many as the Sun. Down here you can see Sunspot 2841 perhaps. Up here Sunspot 2842, which are going to destroy all life on Earth. And here's why. Sunspot 2841 is very scary, and Sunspot 2842 is very big. And there's nothing like big, scary things to destroy all life on Earth. Just kidding, folks. These are pretty minor. Sunspot 2841 here is looking like it's weakened a little bit, although there is still some field complexity with it. We'll show you in a minute. Sunspot 2842 is just an alpha-class sunspot. The likelihood of major solar flare is not really that high. Here's the colorized magnetogram. And we'll see a little bit of a progression of the fields here associated with Sunspot 2841. Still looks like it's a beta-class sunspot. We'll show the ultra-high res images at the end of the video. Let's zoom in a little bit here, since we've shown time and date stamps. So the size of the umbra associated with 2841 haven't changed very much. Let's look at some more data. And here's your diagram of the solar system. We like people to know where things are and what it is they're talking about. And we've advanced that 1 week. There's where things will be on July 18th. The 10.7 centimeter radio flux, the radio output from the upper chromosphere and lower corona, only at 74. Here's the 1 year chart from Solon.info. The black line is the radio flux. The red line is the sunspot number. And we are expecting some geomagnetic unrest here in 2 days. So on the 13th here, NOAA forecasting some geomagnetic unrest early in the day between 3 and 9 Universal Time. KP4 forecasted, as well as for a short period tomorrow. I'm not sure what that's all about, but in any case, that's your NOAA forecast for geomagnetism. A little bit of minor geomagnetic unrest forecasted in the next couple days. Let's take a look at global seismicity. There's a 7 magnitude earthquake drought, which means if you're in an earthquake-prone zone, please have a plan, as earthquake droughts end in large earthquakes. So areas like the ones I'm going to draw in here. So especially these zones, folks, these are the most likely places to see a large quake. So if you're in one of those areas, expect a 7+ magnitude earthquake coming soon, because there's a massive drought. Let me show this bar graph again here. Only one 7 magnitude earthquake in the past 90 days. Earth is well overdue for a 7+ magnitude earthquake. So view any large quakes as possible foreshocks, like this one here off the coast of Oregon here. It's a 4.1, and it's a deep quake. Oh no, it's not. It's 10 kilometers, so a surface quake there. 176 kilometers off the coast. Anyway, let's scroll up the list here. If we miss anything, leave us a comment and let us know. Looks like maybe only one 5+ magnitude quake here in the past 24 hours. A little bit of a swarm happening there near the California-Nevada border once again. Near Markleeville. A bunch of shaking happening there. So here's one of the largest quakes of the past 24 hours. Basically an earthquake lull here in the past 24. This 5.1 occurring in the Aleutian Islands out in the outskirts, closer to the Kamchatka Peninsula than to the Alaskan mainland. Also, here's an extremely shallow quake in California, this one occurring at 1,300 meters above sea level. Here's one in the northern Mariana Islands at extreme depth, 490 kilometers below the surface. So 2 5+ magnitude quakes here happening right in the same spot there. Attu Island, Alaska, the site of the largest quakes of the past 24 hours. Continuing on to see which volcanoes are erupting, and Suwanosejima is on the list. So there's some imagery of the Japanese volcano Suwanosejima. Let's consult the list here at Volcano Discovery. Karimsky now back on the list. Having resumed its explosive behavior, it's producing a 10,000-foot ash plume over the Kamchatka Peninsula. Suwanosejima in the Ryukyu Islands, exploding. 9,000-foot ash plume produced there, as well as near constant glow at the Ontake crater. Suggests that the flux of magma is rising within the edifice. Explosions continue to generate pyroclastic bombs and blocks that are ejected up to 800 meters away from the crater toward northwest. Please don't build a campsite on the base of the mountain. Dakono exploding on Halmahera, 7,000-foot ash plume there. Pavlov on the Alaska Peninsula, reporting seismic activity, including a continuous tremor, although no eruptive activity or emissions from the summit have been observed in cloudy satellite and web camera views. Alert level's been raised to yellow for the Pavlov volcano on the Alaskan Peninsula. Fuego on Guatemala has been exploding, producing a 15,000-foot ash plume of volcanic ash there. Nevado del Ruiz in Colombia exploding, flight level 200. It's a 20,000-foot ash plume. Sangay producing a 19,000-foot ash plume over Ecuador as it explodes. Revenador exploding in the same country there. Ecuador, a bit of a volcanic hotspot right now. 14,000-foot ash plume produced from Revenador. Sabancaya in Peru exploding. Intermittent puffs of volcanic ash producing a 25,000-foot ash plume are enough to remind us not to pole vault the caldera. Tell your friends and foes not to pole vault the caldera by picking up some merch. You can find the link at smashomash.com. Smashomash.org will redirect you. This public service message brought to you by Smash staff and I at massive personal risk and expense. So please don't pole vault the caldera. It could be unhealthful. Solar flaring's been fairly uneventful here over the past 24 hours, although we did see this large B-class flare happen recently. So flaring activity quite low, the likelihood of large flares not really there as the sunspots are looking pretty weak. Here's the proton flux over the past 3 days. No significant proton events to report there. Here's the 3-day chart from the GOES magnetometer. And we saw a flatlining of the magnetometer here for a moment. And let's take a look at the heliospheric current sheet to look at the polarity of the local environment. Now keep in mind, this is not to scale, folks. This is nowhere near to scale. Earth is very far away from the sun, 93 million miles. And this data here is gathered from 51 ground-based magnetometers, as well as magnetometers here at Lagrangian point 5 stereo A and Lagrangian point 4 stereo B. And this is one of the most important pieces of data that we can possibly look at here. It gives us insight into what's going on the opposite side of the sun and so on. It's the top view ecliptic plane field plot, part of the Gong 2 data, the National Sunspot Observatory. So Earth is solidly in a South Pole current sheet. As you can see here shown in red, there is a North Pole current sheet making its way across. There could be a delay. Keep in mind the magnetic environment can change with absolutely no warning. Here's the line of sight ecliptic plane field plot. And you can see that North Pole current sheet approaching there. This dip in this blue line, that's a representation of where the BZ will be located. The top pane of the real-time solar wind that we show daily. Also, we'll show the line of sight coronal hole plot, since the coronal holes associated with the South Pole down there will be the source of some geomagnetic unrest in a couple of days. That's what the NOAA forecast is based on. Protons, solar protons, blasting out of that South Pole-oriented coronal hole. Here's some more imagery of that, as well as our sunspot groups 2841 beta class and 2842 alpha class. So again, the likelihood of major solar flares not really there. And let's continue on. The KP index, a measurement of global geomagnetism, currently at only 0. KP of 0. Due to a weak incoming solar wind stream, I would suggest. And we've just seen the solar wind speed ramp down here over the past about 14 hours. Current conditions are solar wind speed about 375 kilometers per second, solar wind density 5.94 protons per cubic centimeter. We also just recently did see a signal start to come through here. We saw a divergence in the BTBZ, the total field and orientation to one of the poles, accompanied by a shift in the phi angle. That's the spin moment of the incoming solar protons, as well as a signal in the density, the speed, and the temperature. So a little bit of a new regime coming through here. We'll be keeping an eye on this. Pardon my pun. Next, looking at 4 hours of geospace magnetosphere movie. We show it daily. It's magnetohydrodynamic pressure in nanopascals. And I would expect to see a small reduction here toward the end of this. So I'm typically looking at this for the first time, perhaps just like you are. I don't view the entire geospace magnetosphere movie during show prep. And does the pressure drop at the end? Not really. Looking pretty homogeneous there. Let's look at ground magnetic perturbations here. Geospace delta B changes to Earth's B field during a polar excursion. A geomagnetic excursion is a thing that's occurring right now. The South Pole has left the Antarctic continent and is someplace south of Australia. And the Earth has 2 north poles, one over Canada and one over Siberia. The net North Pole is someplace between Greenland and Svalbard. In any case, not a lot of changes happening right now. Not a lot of induced magnetism from the incoming solar protons and the Bremsstrahlung associated with them. Now, we do stream regularly to Twitch. So thanks to our viewers over there on Twitch. Twitch.tv/smAshomash is the URL there. And we will stream our cosmology segment and meteorology segment today live to Twitch. So we just did a cosmology segment. Make sure you check that out. If you haven't checked out our cosmology segments, you can find them at youtube.com/smashomash/playlists. We're pushing the 200 videos mark for our cosmology segments. And there's all kinds of cosmology subjects there. Let's get back to the environment around Earth. It contains lots of electrons. And we don't see any charging hazards. Those electrons can charge up satellites, but they currently are not doing so. Here's the 1-year chart from Solon.info. Here's the 3-day chart of the relativistic electrons surrounding planet Earth. Nominal levels there. Here's the forecast model for the relativistic electrons. And expecting a small uptick, I would expect a small downtick when the coronal hole wind stream arrives. So that's a characteristic of coronal hole wind streams that we see all the time, especially during low levels of solar activity. Here's the diagram of the Earth's Van Allen belts. Feel free to pause the video. Distances are shown in miles, and here's the total electron content forecast, showing you a visualization of electron density through the whole air column. I like this one in that it shows GPS errors, and I use GPSs on the regs. I'll let it play through a second time here. And when we see low levels of electron flux like we do now, we tend to see more chaotic areas of electron density here. Quite low levels there of electron flux. Next, we're going to show you the ionosphere. Here's one slice of the ionosphere, the F layer, located at about 300 kilometers of altitude. Here are the vibrational frequencies, and we're seeing anomalies here over places like North America and the Pacific Ocean. So some surprising high vibration regions here happening over North America there. You can see those. Also places like Greenland. Seeing some surprises there happening in the ionosphere. It does give us some insight into the Earth's magnetic fields, just like the electron flux does, as electrons are very light in mass. They're very low mass particles, and they respond more quickly than heavier things do. It's why we show the data on the regs. Anyway, here's the latest image coming through at 8:30 Universal Time. And we just did a meteorology segment. Here's a teaser. That's what's going on in the U.S. water vapor map. Make sure you check out our meteorology segments. You can find all of our videos at youtube.com/smashamash/videos, or even better yet, youtube.com/smashamash/playlists. Here come additional bonus features, starting with the El Teide. The El Teide ground-based solar observatory here in El Teide, Spain, in hydrogen alpha. And you can see some filaments up here associated with Sunspot 2842. Here's Sunspot 2841. Nothing to write home about. Let's continue on. To thank our patrons, the true source of funding for the content. Thanks, patrons. Please consider becoming a patron if you want all kinds of information nobody else gets to see, links and all kinds of other analysis, as well as multimedia and early alerts. If you want to know what's going on with the sun long before anybody else, become a patron at patreon.com/smashamash. Help us to fund and grow our operation and continue creating more, better, and more varied content. Thanks again, patrons. Here comes some more solar data in the form of the GOES 16 thematic map. There are still some filaments here north of these coronal holes. Also some prominences, some filaments hanging off of the limbs of the sun. Some crown prominences, some little minor crown prominences happening, especially at the North Polar region. Here are some ultra-high resolution images. It's Sunspot 2841, which looks like it's going to evaporate entirely. This is going to be downgraded to an alpha class sunspot and probably not a sunspot at all throughout the day today. It looks like it's shrinking promptly. And Sunspot 2842 looks like it's actually shrunk as well here. We do see some penumbra. It's only got one umbra of one polarity. So here's 2841, looking weak, looking like it's going to evaporate entirely. Possible new region forming right here. In fact, let's go back to the intensity gram just to make sure that we haven't missed one. There could be one form in there. I do see a little bit of a darkness. There's the full disk and colorized magnetogram. Here's Sunspot 2842, alpha class all day. Clearly no opposite polarity umbrae there. And here's one more set of SDO data. So that right there is 3 wavelengths, folks. It's 2 ionized states of iron in the form of 211 and 171 angstroms. That's the green and the blue. And then ionized helium, which is the red portion, 304 angstroms. Anyway, most of the activity in the solar eastern portion right now. Thanks for tuning in to the Daily Space Weather. Don't forget to press like and subscribe. Tell your friends and foes about the channel. Please share on your social media, as we need your assistance to get the videos out there. The algorithms, shall we say, aren't helping. And may that solar wind be at your back. The Daily Space Weather, a normal feature of the Smash News Network. Least busted name in news.